Good afternoon. I would like to get started with a presentation about the Everspan product. It's a new product category actually from Sony for long-term storage, for archiving. And we have implemented some new technology into this device, and I want to introduce that to you. And maybe you also have some questions. It's a small audience here. We can do a little bit of a Q&A at the end of this presentation. We have announced this product yesterday, and upstairs in booth B3, we are exhibiting the product, functional unit, and you can see the product working. So what I want to do today is I want to show the Everspan technology, what is the heart of it, drive and media. I want to go through that, what we have changed here compared to other optical technology. And then I want to go into the Everspan library itself, product features, customer benefits, and then talk about availability and the roadmap for the product. We have designed this product because we feel there is a need, or we know there is a need for long-term storage and for for longer retention periods. So as we go into the higher capacity ranges and we have a requirement for long-term retention of data, and there's a problem. We have tape, we have hard disks, but the life of these technologies does not usually meet the life of the data. So we designed a product which is using optical technology and which is using a media which lasts basically forever. Actually, we give a 100-year media warranty on the storage medium. What we also did is we increased the capacity of the media and we improved the performance of the drives. And we all packaged it so that we have a cost-competitive product to LTO7 solutions or to hard disk solutions, actually cheaper than hard disk solutions. And I want to introduce this to you and explain further what we are doing here and how this system works. So in the past, we had CD technology, DVD, Blu-ray, you know all this, but this is the consumer level products. And we completely made something different. We could not be bound to the specifications of the consumer drives, so we developed something new we call the Archival Disc. And it was introduced actually in 2015. And now we introduce the product where we apply this technology. Media capacity for the Archival Disc is 300 gigabytes. And these 300 gigabyte capacity is coming from a dual-side medium. So we have 150 gigabyte capacity per side. Each side has 3 recording layers. And so this is basically what we did on the Archival Disc side. We increased the capacity from Blu-ray and we made it a dual-side medium. On top of that, we improved the reliability of the medium so that we can do a 100-year media reliability, a 100-year warranty for this product, for the medium. Then we also improved the drive. Since we have dual-side media, in the past, these libraries used some mechanism to turn media around. All that takes time, so we didn't do that. We use lasers on both sides of the medium. Here you see we have laser on top and bottom, and each laser is capable of having a transfer rate of 45 megabytes per second. But 45 megabytes per second compared to LTO or to hard disk still seems slow. So that is why we introduced an array head drive. It's the world's first 8-channel drive. So we have 8 lasers, 4 on top and 4 on the bottom of the medium, which give us then an average read transfer rate of 280 megabytes per second. That is, if you compare that to a hard disk, or if you compare that to LTO7, for instance, the latest tape technology, that is as fast as these technologies. And that's a complete difference to the previous generations, consumer generations of optical storage. So what you see on this picture on the right-hand side is you see the lasers. There are 2 pairs of lasers on the bottom and on top. So what we did on this picture is we flipped a drive open, and you see these 2 pairs of lasers. So what we do in writing, when we write to this drive, we write to one laser and then do a write verification with the other laser while we are writing. That's part of the write process. And when we read, we use all 8 lasers for reading. But you also actually, what you get from this is, if, for instance, one of the lasers would fail, well, you have one of the 8 lasers failing, but 7 lasers still work, and you just have a smaller performance impact, and you can still use the drive. On the left-hand picture, you see a plot for the read transfer rate. At the inner diameter, we start at about 180, 185 megabytes per second, then increase higher, and then the peak transfer rate over most of the medium is at 315 megabytes per second. So that gives us an average transfer rate of 280 megabytes per second. The drive has a SATA interface, just a single SATA interface, so you just connect SATA, and then you get your 280 megabytes per second. We also use a high reliability laser, which gives you about 14,000 hours of write time for the laser. That compares very well with competing products. So we call this drive an array head drive because we have an array of heads in there, and we have 4 on top, 4 on bottom. Then in our system, on the library system, we have 64 of these drives. And that gives us a restore capacity per day of 1.5 petabyte. The sustained transfer rate for this, for the device, for the library, is 18 gigabytes per second. Well, I said before that we give a 100-year warranty on the media. On the right-hand side, you see some specification for 50-year life and 100-year life. And there is actually a trade-off between the temperature and the humidity. Now, you may ask, how are we doing this? We talk about 50-year or 100-year media life. Well, there is actually an ISO specification which defines how you test for the life of these media. Something like that you don't have for LTO or for tapes. You don't have that for hard disks, but you have this for optical media. So there is a specification, a standard, which was developed by NIST, National Institute of Standardization, and that defines the test method for accelerated live testing. So this is how we got to these numbers. And so that means this is not a test done by Sony. This is done a test according to industry standards. Now, to increase the reliability beyond the normal high reliability of the media, we apply erasure coding to our system so that we write to up to 16 drives in parallel. That is configurable. You can also write to 4 drives and then have maybe 1 drive offline, or you can write to 16 drives and have up to 4 drives offline. So that erasure coding is basically the same what is applied in for hard drive solutions. The optical technology is a non-contact recording method. So that means the head is never in contact with the medium. What that means is you can read from this medium as often as you want, and you can load this medium into a drive as often as you want. The reliability of the medium is not impacted by that. This is much different from tape. A tape you can only load so many times into a drive. And with tape, also with hard disk, there is an end of life, a defined end of life. If you use it, if you read it, you reduce the life of the medium. You don't have that in optical. So what we then do is we use these technologies, the disk, the drive, and install that into a scalable library, and I will explain what that means. But our goal was here to get to the lowest cost per gigabyte. And we feel we achieve that. We can be lower in cost than tape solutions and hard disk solutions. So in our library, we integrated the high performance drive, the high density media, then the laser, high reliability laser and media, and that is the package we offer and which we show up functional in our booth B3 upstairs. So this is a base unit, what you see here. The base unit on the left side has what we call drive unit. This is where the optical drives are. Then there is a robotic, and the robotic brings media to these drives. Now we have up to 64 drives. They can all run concurrently in parallel. And that leads then to a performance of 18 gigabytes per second. The acquisition cost of this system in cost per gigabyte is the lowest in the market. We can be better than tape and better than hard disk. An additional advantage of this solution for long-term storage is that the power consumption of the system is very, very low. For 180 petabytes, we have a power consumption of 7 kilowatt average, and in standby mode, less than 2 kilowatt. What that means really, I mean, when you compare that to a hard disk solution, just one rack has about, again, also 7 kilowatt, and that is about 4 petabytes per rack. So 4 petabytes in hard disk have the same power consumption as 180 petabytes with this system. So here is a little different view of the system. On the left-hand side of the unit, we have the drives, and there is a robotic which loads the drive, and then we have towards the right-hand side a robotic which loads the trays towards the left-hand side towards the drives. Now on the right-hand side of this picture, you see under this kind of yellow hood, that is what we call expansion unit, and we can have up to 14 expansion units. So we grow this system in a row so that you get you have a width where the width of the system, where the drives are, and then we grow this in a row fashion, and that is how you do this. You do these installations in a data center. So this product is really designed for data center. Then when we add 14 expansion units, we get to 181 petabytes with the current 300 gigabyte system, with the 300 gigabyte media. The dimensions of the rack comply with OCP standard dimensions for racks. So we seamless fit into a data center environment. Here on these pictures, you see a little more about the robotics. Well, it's a little dark, but on the right-hand side, you see the linear robotics, which is loading a tray, a medium tray. And then on the lower picture, there is a staging area for trays. And then on the upper left picture, we see the robotic for the drives. And what we do here is we load 4 drives at the same time. We have a robotic which loads 4 drives in parallel. And then we have stacks of media, and we go to one series of 4 drives and load them, then go to the next row of 4 drives and continue to do that until we can load a total of 64 drives with one load of media. So in this picture, you see a full configuration of the Everspan product. On the left-hand side, you see the base unit with the drives, and then the system can grow in the row design, so that the total length of this system is up to 55 feet. And that is then a 181 petabyte configuration. When we expand the system, we increase the power consumption only in a small amount. So you can easily expand and have a very little impact to the power consumption of the system. We launched the product actually yesterday. Today we show it functional upstairs. We have customers in beta with this system now. We install these systems at data centers, at cloud companies, national lab and banks at this time. And we work with development partners on this, and that is where we have the beta systems installed now. The product demonstration we do up here is in booth B3, and we do our first production unit shipments in July this year. We follow the roadmap for the media, which was announced earlier last year in 2015. The next media capacities will be at least 500 gigabyte and at least 1 terabyte. And we expect these capacities to come to market in the next about 5 years. We will have also other capacities, and we expect that every 1 year or 2 years we will do a cadence of improved technology. So if you have an interest in this product and want to get more information, please visit us upstairs in booth B3 or go to our webpage info@everspan.com. Well, it's a smaller room. If you have any questions about this product or want to get some more information, we can do this here, or we can also do this upstairs in the booth. Any questions you may have, please? Yep, go ahead. To install additional expansion units will require a downtime of about 2 hours for the system.
And that's for a full media swap out, or that's what I'm talking about. We have new technology, and you have a new cartridge type that has a higher capacity. But now I've got a system installed that's got a lot of 300 cartridges.
Yeah, okay. So if you have 300 gigabyte media, with all future generations of drives, they will be read and write compatible. Now, to replace drives can be done with the unit in operation. So we have a procedure that for a hot swap of these drives. To replace a drive takes maybe 30 seconds or something like that. The drives we have 4 drives on a tray. We bring out the tray. There is a central positioning screw for the drive. So the drive replacement is a matter of like 30 seconds. Mm-hmm. Yes?
You say it's not Blu-ray, right?
No.
So what do you call it?
Archival disc. Yes.
Yeah, and Sony's been working on that for a while, right?
Yeah, about 2 years, yes. Mm-hmm.
But the laser itself is similar to the Blu-ray laser?
It's a blue laser, so the wavelength of the laser is the same, yes. Mm-hmm. Yes. But as you may appreciate, with the consumer products, for recordable media, there were many manufacturers, and there were, better and, let's say, less good media. And we want to avoid this. So the standard we are following here, we are working on with Panasonic, and right now the media are produced between Panasonic and Sony. And at this time, there is no other manufacturer. That doesn't mean it has to be like this all times, but at this time, we really want to control manufacturing of these media because, I mean, we give a media warranty of 100 years. The goal for the 100 years really is to eliminate migration cycles, and we believe we can achieve that with this product. Any other question? Yes. Well, the dollar per gigabyte is a question I get always. And it's first of all, it's cents per gigabyte, but that doesn't help, I guess. But if you today buy a hard disk solution, let's say on WEC level, you probably will pay in the order of 5 to 6 cents per gigabyte for a hard disk solution. I can assure you that we are well below those numbers, and if you get up to the 180 petabyte solution, we will be much lower than that number. I cannot and don't want actually to give you this number right now, but you know, the system can grow to 180 petabytes, and actually with erasure coding, it can grow across 4 rows to 720 petabytes. And that really impacts pricing. I hope you understand that. Yes?
I had a question about the dimensions. You mentioned they are OpenRack compatible. And so when you mentioned that, is that the width of a single rack, height, depth? Which one of those are you
I'm referring to the triple. You call, or the OCP standard calls this the triple WEC. And those dimensions we follow with this WEC here. Actually, also for your, I get back to your questions again. Here, this is a 300 gigabyte medium. It's kind of a look-through medium. You can see that. And that's the dual-side drive here, single SATA interface. And we have lasers then on top and on bottom. Any other question? Yeah.
So I saw upstairs that the trays, you have like stacks of
Media.
media.
Yes.
How many are in a stack? But still, the drive only reads one at a time, right?
Yes. So why do we have these media trays? I mean, you're well informed here. So we have stacks of 16 media, and we have 4 of those stacks in one of our trays, which we load with this robotic. We use these trays in our manufacturing line. So the manufacturing line loads media direct into these trays. We seal the trays, and this is how they arrive at a data center. Nobody else is touching the media in between. So we have a chain of custody for the media, which is important in certain markets, and that's why we do this. I also want to add that this type of robotic, which we are introducing here actually right now, is nothing new. We are using this type of robotic in our manufacturing lines for many, many years. So what we do here is we apply these robotics to the general market, and you know, we know very much about the reliability of this product.
How long it takes to reach the longest time to reach
Or to get to the first byte? Yeah, first byte, the longest time is in the order of 100 seconds. But what we do then is we bring that tray to what we call a staging area, and then we load the media. And then if there's another request for a tray for media, then we load this already to the staging area, so that on the second request, the time is reduced dramatically. Any other question? Yeah? It can be configured, but typically if we write across 16 drives, we can tolerate up to 4 drive being offline, or let's say 4 media failures, however you want to do this. So about 25% of the hardware can fail. And what we do with this is you can span the erasure code across 4 rows, And then one complete row can actually be offline and you still have access to your data. Yes?
What was the most challenging part about developing this system?
Well, this is a major development. And first of all, I would say the drives are, I wouldn't call it a piece of art, but you know, to develop an 8 laser drive is something else. But on the other hand, look at other technologies, at hard disks or at tapes. I mean, an LTO7 tape has 32 channels. So, I mean, we just went down the same road and applied that. But we are doing it for the first time, and so that was a major challenge. And then I think the whole robotic, to make these two robotics play together is a major thing. Also, one other development we did is the SATA signals we turn into an iSCSI signal. And so we had to do a development there so that to the outside world we represent the drives as iSATA devices. But not just that, we also have an interface for tape. So if somebody has a tape solution right now, he can seamlessly use this library and the optical drives look like tape drives. Those things are major developments. But we do that also. We did that with customers who had the request, and you know, it's a corporation. It's not all just Sony. Okay. If there's no, oh, one more, yes. Yeah, the lasers have a reliability or mean time between failure of 14,000 hours for writing. That's very important. So when you write continuously, 14,000 hours is the life of the laser. On reading, the laser would virtually last, you know, not forever, but it would last much, much longer, a multiple of that number. Well, if there's no other question, then I thank you for listening in, and please, I would like to invite you to come upstairs and take a look, and I will provide you with some more details. Thank you.